Hi everyone, good morning. So this is Sudhi here again, and today's topic is about GitOps for Kubernetes using Argo CD. So let me divide this into two parts before going further. So I'll be telling you first what is GitOps, okay, and then we will see how we can use Argo CD in order to deploy your applications using GitOps on your Kubernetes cluster. Okay, so that's how we are going to see today. So first of all, let us understand theoretical part and then we will go with the practical session. So first of all, everybody has to understand what is GitOps. So to be straightforward, GitOps is not a tool. Okay, even how we talk about DevOps, right? DevOps is a culture which we adopted into our IT industry in order to bring the developers and operations engineer under one platform using some tools, okay, to simplify our jobs as well. So similar to that, GitOps is also one of the platform which is providing you to use this Git as a source of truth, which means that every developer knows about Git, right? Source code management tools like Git, we have SVN and all. So Git is more popular because we have so many advantages when you use with Git, okay, because of its features, logging, verifying, revert, okay, rebase. There are so many things which we have to discuss, okay. So that Git we are using as a source of truth. So what do you mean by source of truth? Source of truth in the sense, whatever I have saved in my GitHub, that is what I want to deploy on my Kubernetes cluster. So my Git will be the source of truth for my Kubernetes. Okay, let's forget how we will deploy and all. That is the second part. In the first part itself, first we need to understand how I can push my code to my GitHub. It can be Helm charts, it can be your manifest files, your customized files, whatever it is. Everything I will push into my Git. So my Git is my desired. Okay, so that is what I am desired to have my particular cluster to be deployed, and your Kubernetes cluster should have that particular whatever you have mentioned in the Git, that should be deployed. If it is not deployed, it is out of sync, right? That's how it is. So to be straightforward, GitOps is nothing but your operations engineer or developers will be using Git as a source of truth, okay. And how will you implement? It's a continuous delivery or it can be a continuous deployment for your cloud native applications like Kubernetes. Now, so next question would be like everybody could be asking that, so do we need to learn any new tools? No. So already like developers knows how to use Git and they know how to implement the continuous deployment as well using something like Jenkins. They know something like how to use a different tools in order to deliver this continuous deployment. Okay, so we are adopting that into our GitOps. Okay, so GitOps is a source of truth which I already explained. For a production service, it's not that what do you say 100% used. They are still in the testing phase actually. How to implement that, how effectively it is working on your production servers and all, it is under implementation. But your testing purpose for your staging servers and all, you can adopt this particular GitOps with an efficient way. Okay, now so it will help. So GitOps will help me to deploy my applications or update my existing applications in the repository. So whatever I have mentioned in my GitOps, let's say today I want to deploy some Nginx application on my Kubernetes cluster, or let's say I want to deploy my MySQL application on my Kubernetes cluster. Now what I want to do, first, generally what we used to do in Kubernetes, we used to write a YAML file. Let's say I used to write some deployment. For that I used to write a YAML file, and then I used to expose that particular deployment as a service. For that also I used to write a YAML file. Okay, so this is how the general procedure which we follow. Now what we are saying, instead of you logging into that particular Kubernetes cluster and deploying that particular applications, now these YAML files will be pushed into Git. Okay, so when the code has been pushed to the Git, this code will be applied to your Kubernetes cluster using Argo CD. Okay, Argo continuous delivery or continuous deployment. Okay, so this is what we are trying to achieve. That's a whole picture of this particular session. Okay, now you might ask me another question like, we have infrastructure as a code, then how it is different from GitOps? I already have an infrastructure as a code, so then do I really need to use GitOps? There is a slight differences actually. It depends on where you are using and how you are using it. Okay, it all depends upon these two factors. Any tool, when there is a differentiation, when you have multiple tools for the same functionality, you have to see 2 points over here. Okay, when to use, how to use. Okay, so infrastructure as a code is a version controlling system agnostic. Okay, whereas GitOps is uses only Git. See, infrastructure as a code, in the sense you have so many tools to implement that, like Git, SVN and all, which I discussed earlier. But GitOps, in the sense, the name itself will tell you that you can use only Git for your operations. Okay, to build the image or to push the code to the repository, whatever it is. Okay, this all will be done through only Git. You cannot use SVN, or you cannot use Bitbucket or any other tool for this. Okay, that's one thing. And IaaS deals only with the underlying infrastructure, whereas GitOps manages KATs on top of it. Means, let's say infrastructure as a code, let's say you have written something, you can do some underlying infrastructure configuration and all, like Ansible and all, we can use it and we can do something else on that particular infrastructure. But whereas GitOps, on top of your Kubernetes, you are trying to deploy your applications. Okay, so you're managing above the Kubernetes, right? So that's a major differences between infrastructure as a code and GitOps. So now you understood where we have to use, when we have to use, right? With these 2 points. Now, how it looks. Generally, this is the standard flow in order to use a continuous integration and continuous deployment. Okay, so continuous integration, in the sense, let's say I am writing some code. It can be anything, some XYZ, or you are writing some YAML file to deploy your application or something else. Now what you will do, you will be writing it. Once you have written it, you need to store somewhere, right? Okay, so that is nothing but your Git. So you will push your code to the Git. It can be a developer or it can be an operations engineer. So now whatever you have pushed, it will build it. Build, in the sense, let's say I pushed a Docker file. Okay, so when I integrate that to my any other what do you say, image registry, okay, automatically it should build an image from the code what I pushed into Git. Okay, let me try to implement this first. Okay, let's say I want to show you this first, how we can achieve this continuous integration, okay, without using GitOps. Or let's say it is actually GitOps. Okay, here what I will be using, I will be using Git, and here for building purpose, in order to build the image from the code which I pushed into Git, I will be using Docker Hub itself. Okay, so you have to create an account in the GitHub, and you have to create an account in the Docker Hub as well. Okay, so let me show you that first. So this is my Docker Hub account. Okay, let me try to create a repository. So here I will be giving something like Ubuntu hyphen Nginx, for example. Okay, this is the repository name which I gave, and I want to make it public because I am using a free license. They will give you only to create an image with a private repository, only one. Okay, only you can create one repository as a private. You cannot create, since we are using a free license key. And after that, you can just create it. Okay, so here I'll be integrating my Git to this particular thing. I'll tell you how to create this later, but let us try to create a repository first. Okay, so just create. Now the repository has been created, right? After that, go to your GitHub. Okay, so here in the GitHub, I have created some files. You can see here, Docker Hub. It is using Ubuntu 18.04. This is my maintainer details. And after this, I am executing update command in order to install these packages. Okay, so IP utils -ping and then IP route to. So these are the two packages which I can, if I install these packages, I can execute IP commands in the container and I can execute ping command in the container. For that reason only I am installing these packages. After that, in order to install Nginx on my Ubuntu container, so I am trying to install the Nginx package. Once this is installed, I am copying my custom index.html to this particular location. So when I try to curl my container IP address, I need to get what I have written in the index.html. So what I have written in index.html, if you go to that, here you see welcome to Nginx on Ubuntu 18.04. So this is what I have written, right? So go back here and then go back to the Docker file. That is what I have written. I am copying that particular file to the default root directory of your Nginx. Once it is done, I am exposing this particular port number 80 and I am running this particular command in such a way that your Docker service will be running in the daemon, means in the background. Okay, so this is what I have written in this GitHub repository. You can also do the same thing. After this, what I have to do? Now I need to integrate this particular GitHub repository to my Docker Hub. How I can do that? Go to the build. So here link GitHub. Okay, so here I need to select my repository name, and which one you want to select. What is that name? It is Ubuntu-images, right? Let's scroll for that. So I need to search for Ubuntu-images. You can see there, right? And then build location. Auto test, yes. Internal image pull request, if you want you can give, or internal and external pull request, if you want you can do that. Repository links off. I am just doing that off. And here, which branch you are using as a reference to build the image? I am using the master branch. I have only master branch right now, which is now renamed as main. Earlier it was called as master. Now they have renamed it to main. Okay, so that's how it is. You can do the same thing. Okay, you can mention main as well. Source branch is main. Okay, and the target tag is nothing but latest. I just added this particular tag as latest. Okay, and the Docker file is this, and the build context is in the same location itself. Okay, now save and build. So it is telling you, okay, now you can see it is going on. You can see it is in pending state, means whatever the Docker file you have written here, based on that it is trying to create an image for that. Okay, to show this particular proof whether the image has been built with the custom details what I have passed, I will download this particular image and I will show you. I will try to create a container using this image and I will show you whether it is working as per the expectations or not. If you see here, you can see this particular repository is linked, GitHub repository, and you can see the build process is going on, which means that it is building the image, and you can see the branch. Okay, so let's wait until it is done. As of now, auto test is off. If you want to do an auto test, you can set to on, which means that when you do an auto build, when you do a git push to this particular repository, automatically image will be created, okay, with the new changes. So that is always recommended to do. You can do at any point of time. You can just go to the settings and you can do that. Okay, you can configure automated builds. You can just go here and you can enable the automatic build. So let it be done. This is how the continuous integration is built. Okay, for the images perspective. Continuous integration in the sense there is a tool who will keep on monitoring your source code management tools like Git, SVN, Bitbucket and all. Here my Docker Hub is monitoring this particular GitHub. Whenever it sees a new change, automatically image will be get pulled. Okay, image will be built actually. So that is called as continuous integration. Okay, so this is how. Later on we will see with Argo CD how to do a continuous deployment with Argo CD, what I have told you on the Kubernetes cluster. Okay. It all depends upon the internet speed and all. So sometimes you can ignore if it is taking long time. I will try to refresh this and see. Now you can see it is in progress still. Let's wait. So it will tell you it is in queue. Right now this color in the sense, representation in the sense, it is in queue. You can see status is in progress 3 minutes ago, build time is 1 minute, queue time is 1 minute. If it is in green color, then it is successful. If it is in red color, something got failed. If it is in hash color, it is something has stopped. Okay, maybe you have interrupted or someone has interrupted. Anything can be possible. Now you can see it is successful. Okay, you can see the image was built successfully. How you can see that? Go to the general section, and here you can see the image details. You can see the tag is latest, and this is the image name, Ubuntu-Nginx. So let me try to pull this, and let me try to create a container and show you. So this is my Kubernetes cluster. I can execute Docker commands over here. Just a second, guys. So now let me try to execute Docker commands over here. Okay, so Docker pull. So I need to give my repository name. So the repository is this is the name. Okay, I need to give this, and then I need to give the image name. So it's a public image. Nginx. So you can say automatically it has added a tag called latest. Okay, it will contact to that particular repository, and then if that repository is available, then it will download. You can see it is getting downloaded. Then after this image was downloaded, I will try to create a container, and I will try to curl that particular container, and I will see whether I am getting the same details what I have passed. In the index.html, what I passed, welcome to Nginx on Ubuntu 18.04. So I need to get the same thing. So now Docker image ls. Okay, so this is the image which we have. Let me create a container. So Docker run, Docker container run also we can use, -d hyphen name test -nginx, and then I don't want to use any port forwarding and all, just I will directly use my image name :latest. So now the container was created. So I want to see the latest container. You can see it is up and running. Now if I try to inspect this container, I will come to know the IP address. What is the IP address? 172.17.0.2. So if you call this, okay, so this was happened because I will tell you there are two locations. Okay, so here the problem is under var lib www.html also you will have the same thing. Let me show you that proof as well. So docker exec-ti test-nginx. So in that image I would have done that as well. It's my mistake. Let me show you the proof. So user share nginx html index.html. You can see this. Welcome to Nginx on Ubuntu 18.04. I got this right. Actually the same file can be copied to another location called user share nginx html index.html var www html index.html. Okay, so let me exit from here. Now if I try to curl this, you got this. Okay, so that's a silly mistakes. Okay, that we can ignore. Our concern is like whether whatever we have mentioned in the file and the docker image, whether it was built as it is or not. It was built, right? So it is a continuous integration. So where I have not done anything manually, I have not done any I have not executed any command to build the image. I have integrated my GitHub to my Docker Hub. Automatically when I pushed my code to the GitHub, see this is how it looks, right? So when I pushed my code to the GitHub, automatically a build was happened through Docker Hub, and once it is done, it is saved in the image repository. So image repository is nothing but GitHub itself, right? Now I used that image in order to create a container on my Kubernetes cluster. I did this manually. Now I don't want to do this particular thing manually. It should be automated, means continuous delivery or continuous deployment. Okay, so it's called as continuous deployment. So let us try to achieve that. Okay, so this is what we have done till now. Now let's go to the next step. So yeah, so this is what we are trying to achieve right now. Now there are two types of GitOps that we can implement, which is also called as strategies. What are the GitOps strategies? There are two strategies. One is pull based and one is push based. Push based in the sense, when you push the code to the GitHub, automatically it will push the image to the image registry. So this is what we have done, right? So and then it will update the changes in the environment repository as well, and then automatically it will trigger another job, okay, in the pipeline of CD, and then it will deploy the applications in the environment. That's how it is called as push based GitOps strategy. This is one of them. And there is another strategy called pull based. Okay, so pull based in the sense, you can also see another diagram which represents the push based strategy of GitOps. Okay, which means that you can use Jenkins here. Jenkins can be used Ansible, Terraform or kubectl commands in order to deploy the code in the infrastructure. Okay, infrastructure is nothing but here it is Kubernetes cluster. Now let us see pull based. So always it is recommended to use a pull based strategy in the real time or in the production server. Okay, so what does it mean? Okay, so let's divide this into two parts. Okay, till here you have seen it, already you have seen this, right? So we are writing the code and we are pushing it to the repository. Once a repository it is pushed, automatically using a build strategy like Docker Hub and all, we have converted our image into Docker file into image, and that is pushed into the Docker Hub registry. This is what we have done. So even that particular updates can be pushed to the environment repository, which is nothing but a GitHub or whatever it is. Again, you can use that GitHub, or you can use a JFrog repository and all. Now on the deployment side, we will be having an operator. Operator is nothing but your Argo CD right now. Argo CD will be deployed as an agent in your Kubernetes cluster. Agent in the sense what? It is not a service. It will be deployed as a pod. That pod will be present in your Kubernetes cluster. What this pod will do, it will keep on monitor for the changes which are saved in the environment repository. If it found any changes in this environment repository, automatically those changes will get applied to your infrastructure. That is your Kubernetes cluster. So this will be done automatically. No need of manual interruption. Only thing what you have to do, this configuration is already done. Only thing what you have to do is nothing but I need to create an operator, or I need to deploy an operator in my Kubernetes cluster. Okay, for this particular experiment we will create a separate GitHub repository to do that particular experiment. Okay, for image registry I have already shown you that experiment which I shown you right now. Okay, for this experiment where I will try to deploy some MySQL or Nginx application in my Kubernetes cluster, I will create a new repository in this. Okay, I'll push some code. Once the code is pushed, Argo CD has to pull that particular code and it should deploy in your Kubernetes cluster. So this is called as pull based mechanism. Which means, why it is called pull based? You can tell it is a push based, right? No. Why? Because your operator is keep on watching your environment repository, which is nothing but GitHub, for example, in our case. Okay, here application repository and environment repository is same for us right now. Okay, so this operator is keep on observing this particular repository like this. Okay, your Argo CD is keep on watching this GitOps approach, means your GitHub. Okay, whenever it finds any change, okay, which is not present in your Kubernetes cluster, automatically it will apply the changes. Okay, as a developers we will keep on writing the YAML files and we'll push it to the GitHub repository. That's it. Now deployment will be taken care by your Argo CD. It will check the state of this particular desired state in this GitHub. If it is not present in the required application infrastructure, then automatically it will get deployed. Okay, so this is how we are trying to implement. So let us try to create a new GitHub repository. Okay, and then later on we will see how to deploy this Argo CD on your Kubernetes cluster. Okay, each and every links I have specified in the slides. Okay, you can go through the slides and you can get the reference and you can practice. Whatever the links I am using right now, everything is present in the last slide. You can look at the references. Okay, each and every link I have pasted here. Okay, so this particular slides also will be given in the video description. You can go through that particular slides, and any questions you can paste me in the comments. Okay, first of all, what I have told, I just want to create a repository. Now let's do that. New, let's give like Argo CD deployment. Okay, Description, if you want to give, you can give manifest files to deploy applications on Kubernetes using Argo CD. Okay, that's what I have mentioned in the description. Let us make it as public, and I want to add a readme file, so then create repository. So now we can see a repository has been created. Now from the CLI, I will do later. Okay, your GitHub repository is created. Let's put this particular part aside. After that, let us try to deploy the Argo CD. So this is the official document where you can refer. Okay, I've already mentioned in the description. Okay, you can go through the slide and you can get the links. Now, what are the prerequisites? You need to have a kubectl command. You need to have a Kubernetes setup. So in this Kubernetes setup, we are going to install Argo CD. Okay, so let us follow the steps. So this is my Kubernetes cluster. Let me remove this container now, which I have created earlier. Okay, now this is my Kubernetes cluster. If you see in the number of nodes, I have one manager node and one worker node. Okay, it is just a 2-node architecture. That's it. One manager node and one worker node. Okay, so now let us deploy that. First, what it is trying to say, so it is asking us to create a separate namespace for Argo CD. So let's create that. Okay, so let's verify. kubectl get namespace. You can see Argo CD was active and it is created 6 seconds ago. Okay, now let us try to deploy this particular application, Argo CD application, in this namespace. Before doing that, instead of directly applying this, I just want to download. I want to do a slight modification. Okay, let's see what we can do. Download it. Here Argo CD is having a dashboard. In order to access that particular dashboard, for that particular Argo CD server service, I need to change the type of that particular service from cluster IP to node port, so that I can access from the node IP address. The dashboard I need to access, right, for that reason. Okay, so let's open this, go to the bottom, and here if you scroll up, this is your actual deployment of your Argo CD server. Okay, so that's it is. So now you can say this is your Argo CD deployment resource. Okay, so this will be the application which get deployed, and after that you can see there are so many other applications which has its own responsibility. One is for repository, one is for database, okay, and one is for synchronization. We need to go to the service, the two Argo CD server service. You can see here Argo CD server. For this I need to mention the type under the spec type. I need to mention node port. Okay, so let's save this and come out. Now you can apply this. Okay, so kubectl. Now if you see that you don't have anything created under that namespace Argo CD, you don't have any resource created as of now. So let's create this. kubectl create -f install -n. Don't forget this. Okay, you need to deploy in Argo CD namespace. You can see everything got created successfully. Okay, let's monitor this. It's under creation process. Let us wait. Once these containers are up and running, then we are good to go. You can go to the browser and you can access the dashboard of your Argo CD. Let's watch this. Instead of all, I need to give pod. So it is under creation process. Let us wait. Now we can see all these pods are showing as running status. Only one pod is pending. It is in pod initialization state. Let's wait for that also to be completed. That is dx-sub. So Redis is also up. Almost everything is ready. Only we are waiting for index server, Argo CD -index. So yeah, that is also running. So now if you look at the status of all, you can see all are running, and this is the service which we have created, a node port. You can see this port number. Okay, 31910 31901, right? So my node IP address is, you need to give HTTPS since it is a secure communication, 192.168.0.130. Okay, sorry, 0.60. And then what's the port number? It's 31901. So 31901. So go to advanced mode and then proceed. Now you can say it is asking you to give the username password. So here there is one thing which you have to remember is nothing but, first of all you need to install the Argo CD package. In order to execute the Argo CD commands, okay, utility commands, you need to install this particular binary. So that you can get it from here. Okay, so since I'm using Linux, so I will download this particular package. So how to do that? Wget this. After this is downloaded, I'll show you what need to be done. So I need to copy, once this package is downloaded, this binary package is downloaded, I need to copy this into the binary location so that I can execute as a command in Linux operating system. So I will show you how to do that. So when I'm copying this particular binary to that particular location, I will make it as Argo CD. Instead of Linux AMD 64, I will make it as Argo CD, so that it will be so easy for us to understand. So that is clearly mentioned in the documentation, official document itself, it is clearly mentioned. Okay, you need to download the Argo CD CLI. Okay, in order to execute some commands. Those commands are nothing but, first of all, we need to update the password. Initially, it will have some temporary password. For Jenkins, how we have a temporary password, right? Similar to that, for right now, since this dashboard is created, it will have some password. I don't want that password to be used. I need to give my own password. Okay, so let us say what need to be done. So in order to execute these commands, we need to have that particular package installed. So that is what I am doing right now. So now it is downloaded. Let me move this particular file, means like the binary file, to that particular location. User local bin, I want to make it Argo CD. Okay, now see this Argo CD, when I execute this command, it is giving me permission denied. Why this was happened? Because when whoever it is, whether it is a root user, whether it is a group user, or whether it is others, everybody need to have execute permissions for this particular binary. If you don't have execute permissions as well, you will have the same issue. You can see here, users, group and others, no one has the execute permission. So how to add that? chmod plus x. So for everyone it will add execute permissions. Okay, to which file? User local bin Argo CD. Now if you see this, it was given execute permissions. Now I can execute Argo CD. You can see now it is treated as a executable file. Okay, you got that right? So when you need to execute one particular file as a binary, you have to give execute permissions. Okay, now what I need to do with this? First of all, you need to tell your Argo CD utility that this is your Argo CD server. Where is that? kubectl get all -o wide. Sorry, there is a spelling mistake. Okay, okay, let me give -n Argo CD from this namespace. Now your Argo CD server is running with this IP address internally. Okay, externally if you want to access, you will give this port number, but internally it is listening on this IP address, right? So take this IP address. Okay, so you need to execute a command called this Argo CD login and give the Argo CD server. Okay, now we got the server IP address, so Argo CD login. Okay, and give that IP y. Yes, now give the username. So username is admin, but before that we did a small mistake, so we forgot to get the password. Okay, so what is a temporary password and how I can get that? So you need to execute this command. So this command will try to get the password from the secret. Okay, so that is your password. So by default username will be admin. Okay, and you need to copy this particular password and you need to paste here. Now you can see the admin logged in successfully with this particular context. Okay, now what I need to do? So then you need to update your password, right, with your own password. It's a temporary password. I don't want to use the same password because whoever logs into my particular cluster, they can see the password. I don't want that. Okay, I want to update my password. So to do that, you need to execute this command. Give the old password first. In order to set a new password, you need to give the old password, right? And then give the new password. I will not tell you orally, but I know what password I am giving. Now you can see your password has been updated successfully. So done. Okay, now you updated your password. Go to the dashboard, admin, and give the password what you have set, and then login. Now this is your Argo CD dashboard. Now what we have to do here? Okay, we need to integrate this particular GitHub repository to my Argo CD. Okay, before doing that, I will write some particular YAML files in order to deploy MySQL application in my Kubernetes cluster. Okay, so let's copy this. Okay, go back to your cluster. So in order to download that particular repo locally, in order to do some modifications, I need to execute this command git clone. Clone in the sense, download the repository into your local machine. Okay, because I want to create some directory and I want to create some YAML files under that. Okay, then I want to integrate this particular GitHub repository to my Argo CD. Okay, then I will do that. First of all, let me do this initial setup. So Argo CD, here I just have only readme. First of all, let me create a directory called mysql-deployment. Okay, go to this particular directory. Oh, sorry, mysql. Okay, here this directory is empty right now. Let me create some files. What are those files? Here I already have this sample YAML files. Okay, I will create totally 4 YAML files. One is for service. Let me use this. You need to have some basic knowledge on this, so we cannot discuss more about service. To be simplified, if you want to expose your application, okay, which is deployed through deployment or stateful set or pod or a replication controller replica set, you need to expose through service. Okay, how we did for Argo CD, right? In order to access the dashboard, I changed my service from cluster IP to node port. Okay, so in order for this particular MySQL to access also, you can create a service for that. So I am creating that service.yaml and paste those details. Okay, done. Let's save this and come out. Deployment. So this deployment of MySQL will be done with only one replica. Okay, we cannot create multiple replicas. Why? Because it's a MySQL. Okay, you can see the password which I want to set is nothing but test123, for example, let's say. And then I want to give another entry as fn name mysql root underscore host. Okay, so value should be percentage. Okay, let's save this and come out. Okay, done. And then Then I need to create a persistent volume and persistent volume claim. For that also I'll be creating a separate file for this. pv.yaml. Okay, let's save this. .yaml. Okay. So whatever I have mentioned the resource to be created, once this is integrated to Argo CD, I need to see this particular resources created. Okay. Totally how many resources? 4 resources: service, deployment of your MySQL, PV and PVC. Okay, so these are the 4 files which I have created under this. Okay, so come out of this. Okay, so now you have this particular MySQL directory which you have created. Now you need to execute git status. Now whatever the local changes you have done, you need to save it to the GitHub repository. Okay, so before doing that, first of all I will integrate. Okay, first I need to integrate my GitHub to that particular Argo CD. So take this. First you need to go to new application. Here write something like Sudhir. I just want to mention my name, or you can tell MySQL. Okay, the project is default. Okay, manually, or you want to make it automatic. Automatic create namespace. Okay, so whatever I mentioned, here it should be sync policy should be automatic. Okay, always remember that. And sync options are auto create namespace if it is mentioned over there. Let's say in your YAML file you have mentioned some namespace, it should create and then it should deploy that. So for that reason I have enabled this particular checkbox. Okay, and here you need to give the git. If you don't have git, you can also give helm charts as well. So here I need to give that repository, and then the revision is head, and then path. What is a path? Under this particular repo you will be creating this directory, right? MySQL -deployment. So this directory you have to mention. Okay, after that cluster URL destination. Okay, by default it will be this. Since you are see, one thing you have to remember, this Argo CD is deployed on your same cluster. So in order to contact your cluster, this will be the URL. Okay, in order to contact, see, Argo CD has to contact your Kubernetes API in order to deploy this application what it is mentioned in the GitHub. So to do that, the destination URL is nothing but kubernetes.default.svc. Okay, and the namespace. Okay, in which namespace you want to create? Let's say I will create a namespace called kubectl create namespace. Okay, MySQL. Okay, I want to create that. In that namespace you should create. So MySQL. That is what I have mentioned. Okay, so these things are not needed right now for us. So this is done, and then create. Right now it will throw me some error. It is valid. Why? Because we don't have the path what I have mentioned. Where is MySQL -deployment? It is not there. Why? Because I have not pushed it from my local to the remote repository. So let us do that now. Okay, so git status you can see here. So git add dot, and then if you verify the git status, now it is in staging area. So git commit. So before commit, it is asking you please pass your name and email address, so that it will track that, okay, this is the user who modified this particular changes in the GitHub. Okay, it should track everything, right? So this is how it is. Now git, let me copy paste this. And then I will give my email address. Okay. And then my username. Just I will give Sudhir. Okay. So once this is done, git commit. You need to add some commit message. Okay. Here I will tell that MySQL deployment through Argo CD using GitOps. Okay, this is what the message is. Then save, come out. After this, you need to push the changes to the GitHub. See, right now it is not pushed. If you refresh this, you don't see any changes here. Until you push from your local repository to the remote repository, then only the changes will get affected. Okay. So git push, it will prompt me for username and password. I know what is the username. Oh, sorry, mistake. Username is this, password it will be hidden. Once it is successfully authenticated, you can see it is pushing the changes which I have done locally to the remote. Okay, now if you refresh this, now you can see this, right? So let's specify this now. It is already specified. Let's try to say create. Once it is created, once it is able to identify that particular directory, automatically this will get deployed. Okay, if you want that proof, I think it will take less time. All hyphen o wide and then hyphen MySQL. Let's watch this. You can see MySQL immediately got deployed. Did I mention anything? No, it's deployed automatically. You can see here it is in progress. You can see it is synced. Synced in the sense your GitHub is linked to this particular Argo CD. That is called synced. Progressing in the sense your application is getting deployed. Whatever you have mentioned under this, everything is getting deployed into your Kubernetes cluster. Let's wait and see. So this is called as CICD. So this CICD was achieved through GitOps approach and Argo CD agent. We are not using any Jenkins here to achieve the CICD. So this is a different approach. I hope now you got the clear picture like how to use that GitOps approach to be integrated to your Argo CD. Obviously this will take some time. Let's wait. Now you can see it is showing you healthy. Healthy in the sense your cluster is running successfully. If you click on this, you can see your MySQL. See, this is your what do we say, your project name or application details. This is your application name and this is the SVC which you have created and this is the deployment. There are 5 hidden. Show. You can see now for this particular SVC it is having a MySQL hyphen this endpoint slice and this is the replica set and this is the pod. This is your actual pod. Okay, deployment created a replica set. That replica set will create a pod for us. That is one thing clear, right? So, okay, now this service will create a MySQL endpoint. This is the endpoint. Okay, and this is your endpoint slice, which means that it will contact to that particular namespace. And then here you can see your PVC created and your PV is also created. So everything you can see it from here. If you want to see these specific details, then click on that. It will show you the YAML file, live YAML file, and if you what is desired in the sense what you have mentioned in the manifest means your GitHub. What you have mentioned in the manifest, your live manifest is the same. If you want to see the difference between these two, if something is differing, then you can click on diff. Okay, right now there is no difference actually since everything is there. You can see the event logs. Okay, let us see the pod event logs. You can see this event logs. Okay, you can see the logs as well. You can see this, right? Everything can be seen from here. Okay, so now what I will do, again what I will do, the same MySQL application, earlier what version we are using, let me open that YAML file, MySQL, let me open deployment. Here we are using 5.6, right? Let me change it to 5.7. Okay, then save this. Now you can see there will be a change, git status. Okay, so I need to push it, git commit. Okay, here I will say like MySQL image was updated to from 5.6 to 5.7. That is what we are doing, right? If you want the proof, if you look at this particular deployment, if you scroll down the image section, you can see the container. Yeah, it is using 5.6, right? So now let's see what will happen. Let's save these changes. Okay, Now we need to push it. So these changes are not reflected in the repository until you push it. So git push. Again I need to give the authentication details. Once it is authenticated successfully, these changes will be pushed into your GitHub. Immediately you can see the changes that will get affected. You can see now it's running. Let's wait. Okay, until now, right now it is using only 5.6. It will take some time. Let's go here. It is pushed, I guess. Yeah. Now you will see the message. MySQL image was updated to from 5.6 to 5.7. Okay. If you go here and if you look at the deployment object, live manifest, where is that mentioned? Now it is using only 5.6. Let's wait. So go to the applications. You can say sync. Okay, sync, you have to tell this. If you want to make it auto sync, you can make it, but I don't want to make it auto sync. Okay, then you tell like prone. If you want, you can make it as prone and then synchronize. So now what are the changes you have done that will get synchronized? You can see it is getting progress now. It got affected now. Let's wait. It is actually an auto sync which I have already done. So you can see it is getting progressed. You can see now it is getting created. Okay, did I mention anything? No. Automatically whatever the changes I have done, a new pod is getting created with 5.7. You can see here. Okay, did I did anything? No, I just pushed into GitHub. I have not told to my Kubernetes, but still it got affected. Why? Because this is called as your CICD integration. Okay, this is so easy, right, to manage. That's how it is. Even we can do a rollback as well. Let me show you that. So this is the latest updates. It is in progress. Okay, let's wait until it shows healthy. Then we have to wait. You can see it is under creation process. You can deployment, replica set, and the pod. You can see progressing. You can see now it is done. If you go back to your cluster, you can see it is created successfully with 5.7. Okay, so this is how it is. So now we have sync status. You can see sync, everything is synced. Okay, whatever you have mentioned, MySQL, persistent volume claim, service, this deployment, everything is in sync. Okay, nothing is out of sync. Then if you want to see the history and rollback, you can see here. So now there are two histories. One is this and one is this. Okay, let's say I want to go back to this 5.7 or 5.6. How to do that? Okay, so deployed it 2 minutes ago. This is 8 minutes ago. So this is the old one, right? So let me click on this. You can do a rollback. Okay, just do this. Once you do a rollback, you need to come back here. Once you come back, you can see now it is getting affected immediately. So now this pod will point to this particular replica set. You will see now. Okay, see, look at this. You can see now it is pointing to this. You can see now it got affected. Now if you go back, see now it is healthy. Wait, something. It is under creation. There are 2 event errors. What are those? Okay, that's okay for us. Yeah, now we can see it is healthy. Again it is going on. It got restarted. Let me check the PV and PVC. kubectl get PV comma PVC. You can see this PV was created. So something like PVC is missing here. Okay. Let us see this. There is a PVC. It is synced and it is healthy. It went to a crash debug of error. Let me see the logs. Oh, not found in the sense we need to give the description. Oh, sorry. Shutdown complete. Okay, what went wrong? 5.6. If you are attempting to download from 5.7 or later, please refer this. Okay, I'll tell you the reason behind. It is not the issue with my Argo CD. Since I have upgraded to MySQL from 5.6 to 5.7, after that when I'm downgrading it, it is not supported to downgrade. Okay, clearly you can see in the MySQL logs. So we have to refer some documents, when you're trying to do some downgrade process. Okay, if it is Nginx or something, we could have done without any issues actually. Okay, so I'm doing it live. I have not tested anywhere, so that's the reason we are facing this issue. But anyway, keeping that point aside, you can see now you have done the upgrade and you have done the downgrade as well. But here the downgrade is not supported for this MySQL, which is throwing some error. Okay, so in this way you can manage anything. Let's say for time being you want to make this particular auto sync, you don't want to do an auto sync. Okay, and one more point is nothing but, let's say I want to go to the history and I want to go back to this 6 minutes ago. Yeah, roll back to this. Okay. Again I'm going back to 5.7. Sorry, yeah, 5.6 actually. 6 or 7? Yeah, 5.7. So again it came back to 5.7. So now it is healthy. Okay, so downgrade is not supported for this MySQL because there are some conflicts when you are downgrading your MySQL application from greater version to lower version. Okay, so that will not be supported here. Okay, then putting that point aside, you can test it with Nginx. It will work perfectly without any issue. Okay, so refresh, you can make it the refresh, hard refresh. If you want, you can make it. Okay, if you want to delete this application, you can delete. Okay, and history and rollbacks, you have already seen it. Sync status, if you want to do a sync right now manually, you can do that without waiting for the auto sync. If you want to make it right now, you can do that. Okay, so application details always you can see here. And if you want to make some parameter, if you want to change something, just go to edit. Okay, if you want to remove enable auto sync, okay, let me show you what will happen. Okay, so now if I do some changes in the MySQL, let's say deployment, let's say I will add something like resource limits and all. Okay, limits, resources. Okay, two spaces, limits, and then let's specify CPU and memory limit. CPU limit 1, and then memory limit is, let's say I will specify 1 GB, something like GI. Okay, then this is the change. Now git status, now git add, git commit, update resource limits to MySQL. Okay, that's it. Now if you push this, authentication need to be done, and then give me the password. It is done successfully. Now, though you have updated in the Git repository, okay, though you updated this in the GitHub repository, now this is out of sync. It is not synchronized. Okay, if you refresh this changes whatever you have told, it will not get applied to your cluster. Why? Because it is out of sync. Okay, if you go to the app details, you can see it is disable auto sync. Okay, so this is disabled. Now if you see, now refresh here, earlier it is synced, right? Now you can see out of sync. Why? You need to know out of syncs again. Oh, I did a synchronize or what? Did I click on synchronize? I think so. I clicked on synchronize, means it will hardly synchronize. That's fine. Okay, so synchronize, auto synchronize, if you disable, it will show you out of sync. Out of sync in the sense, what you have mentioned in the configuration file, what you have desired, and what is present in the cluster is different. Okay, so it is not applied. So that is called as out of sync. Okay, when it is really like that, it will show you. Okay, so that is all about your auto sync. Okay, so this is what you can do with GitOps and Argo CD. Everything, all these links, whatever I have mentioned here, it is clearly mentioned in the slides. Everything, gitops.tech, Argo project getting started, you can refer. This is the main document in order to proceed with Argo CD. And GitHub, you can create an account, and Docker Hub also you can create an account. Okay, straightforward. Now let me try to remove this application. Simple, just delete. You can say it is getting deleted. You can say it is out of sync. Why? Because what you have mentioned in the GitHub and in this cluster, it is not the same. Everything is getting removed. You can say application is removed. Once all the resources are removed, then your application is removed. Okay, if you go to your cluster right now, and if you execute kubectl get all, where is it? Yeah, MySQL, you can say it is not there. Okay, even if you see this kubectl get namespaces, I created this manually. Okay, so where is this MySQL? It is there. So namespace was created manually from my side. So that's the reason this namespace was not deleted. Only the resources which are created in this namespace got wiped out. Okay, so this is all about Argo CD GitOps deployment on your Kubernetes cluster. Okay, thank you guys. Thanks for joining for the demo. Thank you so much.